this video, we'll be looking at another way to find the volume of a solid of rotation, called the shell method. We'll work a couple of examples with the shell method and then compare it to the other methods we already know and see if there are situations where one method might be preferred over another. Okay. You can see an explanation of how the shell method works on page 465 of your text. But basically, instead of taking a disc or a washer, we're looking at a shell, like maybe the outside layer of a solid, and taking infinite number of those layers, putting them together, kind of like laminating. Okay, there are a couple of new equations for shell method. Those are on page 466. Please add those to your reference booklet. Okay, let's work a problem using the shell method. Okay, we're asked to find the volume of a solid formed by revolving this region around the y-axis. Okay, so we're going to end up with something that looks kind of like a bagel or half a bagel. Flat on the bottom, but a little bit like a donut. Not quite a donut, there's no hole in the middle. Okay, because the axis of revolution is the y-axis, vertical axis, we're going to use the vertical form of the shell equation and use dx. So let's start with our basic equation. Volume is equal to 2 pi times the integral, and we'll start a to b of p of x times h of x dx. Okay, looking at our picture, this is p of x, the distance from 0 out to my representative rectangle, and then this is h of x, the height at that particular point, and then the width of the rectangle is my dx. So for this problem, and I have 2 pi, and my limits of integration are from 0 to 1. And here's my px, which is just x. And my hx here is x minus x cubed dx. So there's my equation. I'm going to go ahead and integrate that. Now let's simplify first. Now we can integrate which gives us 2 pi times x cubed over 3 minus x to the 5th over 5 evaluated from 0 to 1. Okay, I can see right away that the 0 is going to make all of that 0, so I don't need to do that part. I just need to evaluate at 1, which is going to give me 2 pi times 1/3 minus 1/5. So my final answer is going to be 4 pi over 15. Okay, let's work another problem using the shell method. In this problem we have this shape, and the equation for this curve is h of y is equal to e to the negative y squared. We're evaluating from 0 to 1, and we're rotating around the x-axis this time. Since we're rotating around the x-axis, we want to use that other form of our equation and differentiate with respect to y. So we'll start with volume is equal to 2 pi times the integral from 0 to 1. And then we need h of y, p of y, dy. From the picture, I see that p of y is y, and h of y is e to the negative y squared. So let's put those in our equation. When I integrate, I get negative pi times e to the negative y squared evaluated from 0 to 1. Okay? If you need to look up those integration rules for e to the y, that's one of the reasons you have your reference booklet. Okay, this is now going to give me pi times 1 minus 1 over e. And go ahead and use a calculator approximation for e. So we get a decimal answer, which is approximately 1.986. Okay, we worked a couple of problems now with the shell method. Let's do a little comparing with the methods that we learned earlier. Okay, to tell what's the best method to use, think about this. For the disk method, the representative rectangle that we draw with delta x or delta y as the little width of the rectangle, that rectangle is always perpendicular to the axis of revolution. So for instance, if I'm going to rotate this way, my representative axis would look like this. This is the disk method. Okay, this also applies to the washer method. Okay, if I was going to rotate this way and use the disk method, my representative rectangle would look something like that. In the shell method, let's do this again. If I rotate horizontally, my representative rectangle is going to be parallel to the axis of revolution. And so, of course, if I'm going to rotate vertically, my representative rectangle would still be parallel. It would look like this. So depending on the equations that you're given and the direction of rotation, one method might be easier than another. Sometimes it really doesn't make any difference and you can use the method of your choice. Okay, let's look now at a problem that we worked in the last section using a combination of the disc and the washer method. And now that we've talked about the differences between the shell method and the disc and washer methods, let's look at a problem where choosing the right method could make a difference in how easy the problem is to work. In our last section, we worked this problem where we had kind of a solid base, and then the top part had a hollow area in it. And we ended up integrating twice for the two different sections. In this picture, I've got the same shape again, but since I'm integrating this way, I can use that representative rectangle for the whole area that I'm rotating. So let's see how that would work. Okay, for this picture, we have that P of x is equal to x, and H of x is equal to x squared plus 1. Okay, now using the shell method, we're going to integrate, let's start with volume. Volume equals 2 pi times the integral. We're going from 0 to 1. P of x is x. H of x is the x squared plus 1 dx. Okay, so if we multiply that out, we end up with 2 pi times the integral from 0 to 1 of x cubed plus x dx. Now I integrate, and I get 2 pi. The x cubed becomes x to the 4th over 4, and the x is now x squared over 2, and we're evaluating from 0 to 1. Okay, when I do that, the 0 is going to give me zeros both places, so I don't have to worry about that. The 1 will give me 1/4 plus 1/2, so that's 2 pi times 3/4. So my final result is 1.5 pi. Or you could say 3 pi over 2. So if you look back at the other example of this, I think you'll see that we got the same volume, but in this case I only had to integrate one time. Okay, in this example we're going to look at this long slender shape rotated around the x-axis to create a pontoon. Okay, if you don't know, a pontoon is a usually hollow shape that's put on a boat to assist with flotation. So let's look at the things we want for this, if we use little r of x, that would be 0. We don't have an inside radius. We're getting the whole shape. Capital R of x is equal to 1 minus x squared over 16. Okay, you've probably guessed already by my choosing r, little r, and capital R that I'm going to use the washer method. And actually it's the disk method since little r is 0. So let's write our equation. Volume's equal to pi times the integral. And this is -4 and +4. And then we're going to have 1 minus x squared over 16 squared. Don't need to subtract little r since it's 0, dx. Okay, now I need to multiply this out. And that gives me 1 minus x squared over 8 plus x to the 4th over 256 dx. Now I'm going to integrate. 1 just becomes x. X squared over 8 is going to become x cubed over 24. And then x to the 5th over x to the 4th over 256 is now x to the 5th over 1,280. And we're evaluating from -4 to +4. And our answer comes out to 64 pi over 15. It's approximately 13.4 cubic feet. If I wanted to do this with the shell method, I would have had to solve this equation for x, which is kind of messy to start with. And then the integral would require a u substitution. So a lot more work to do this with the shell method. In some problems, you do have a choice between the shell method and disk or washer. Sometimes it doesn't make much difference. Sometimes there's one that's definitely easier, but you could do it either way. For this last problem that we're going to look at, it really needs to be done with the shell method. Okay, let's take a look. I've got this shape that I want to rotate around this vertical line at x equals 2. Okay, the equation of this curve is y equals x cubed plus x plus 1. And I think you can see pretty easily that trying to solve this equation for x so that I could use the disk method and have a perpendicular representative slice would be a lot of work. So instead of that, we're going to use the shell method on this one. Okay, so for the shell method, h of x is going to be x cubed plus x plus 1 minus 1. We're going to subtract that because of the distance away from the axis. Okay, and then p of x is 2 minus x. Okay, let's write our equation. We're going to be going from 0 to 1. 2 minus x, that's our p of x, times our h of x, which would be x cubed plus x dx. Okay, when I multiply that out, I get 2 pi integral from 0 to 1 negative x to the 4th plus 2x cubed minus x squared plus 2x dx. Okay, so now I can integrate, which gives me 2 pi times negative x to the 5th over 5 plus 2x to the 4th over 4 minus x cubed over 3 plus x squared, and we're evaluating from 0 to 1. Okay, I see here I've got 2 over 4, so I'm going to reduce that and just make it 1/2. Okay, again, if I put 0 in, all of those terms are going to be 0. So I'm only looking at the value for 1. So I've got 2 pi times negative 1/5 plus 1/2 minus 1/3 plus 1 and my final answer is 29 pi over 15. Okay, so this is the shell method, just another way for you to calculate the volume using integrals, and gives you a little more flexibility on choosing a method that's easier to work.